Good morning, students. Welcome to the online classes for Standard 9th being organized by DV Public School Gumla. I am Jeevan Kumar Pandey. I'll be taking some of the physics classes. The first chapter given in your NCERT textbook is motion. In this chapter, basically we have to discuss about distance, path length, speed, average speed, velocity, acceleration, and so on. But before discussing this particular chapter, let me briefly introduce to you some basic units for some fundamental quantities. The most important of them being length, mass, and time. The SI unit for length is meters, which we write as m. Likewise, for mass, it is kilogram. Kilogram symbol is small k and small g. And for time, it is second. Second is denoted by small s. Likewise, the CGS units for length, mass, and time are centimeter for length, gram for mass, and again for time it is second. Let us see the relation between them. For length, meter and centimeters, they are related using this relation. 1 meter, you must be knowing this, students, that is 100 centimeter. Likewise, kilogram and gram also you must be knowing. 1 kilogram is equal to 1000 gram. Why I started discussing this chapter with these particular things? Because it's very important to know the correct units for different physical quantities. Many new physical quantities you will read in this particular course of Standard 9th. You have also read about some of the physical quantities by Standard 8. It's important to know these units. In your NCERT, they are using these combination of SI system. Why are they important? They help you in finding the correct unit of some physical quantities. For example, all of you know about speed. Its formula you know, it is distance upon what? Time. Now if I ask you what are the SI and CGS units for speed, then you can write the answer easily. If you know the formula and if you know these three combinations, their units, you can write these units. See, SI unit for speed should be SI unit of distance by SI unit of time. Tell me, students, distance out of these three, which unit we should use? So distance is clearly one kind of length. So its SI unit is meter. For distance unit, I'll write as meter. And for time, I'll write the unit as, you can see, second. So I can write it as meter per second. I can also write like this, ms to the power minus 1. And how do we read it? We read it like meter per second. The CGS unit likewise you can write as CGS unit for distance, it will be centimeter. So you will write centimeter per second or centimeters per second. Let us take another example for writing SI and CGS units. You also know about density. So what is the formula for density? I hope all of you know the formula, that is mass divided by volume. Now you might feel that mass we can write the unit from here, but what about volume? Volume is not mentioned over here. So let us first try to understand the formula for volume, unit for volume. In mathematics, you must have read about formulae for volume of different kinds of surfaces. You choose any one of them. You can take a cube, cuboid, sphere, anything. The simplest one, cube. What is the formula for volume of a cube? Yes, it is length cube, length into breadth into height. We write for cuboid. For cube, you can write simply as a cube, where a is the side of the cube. Now this SI unit for volume, because it is side cube, side is a length SI unit is meter, so I will write its unit as what? Meter cube. And for mass, what should be the SI unit? It should be kilogram. So therefore, the SI unit for density should be how much, students? For mass we will write kilogram, and for volume we will write meters cube. This you can also write like so, kg per meter cube. And likewise, the CGS unit, how will you write, students? The CGS unit will be, instead of kg, we will write gram, and instead of meter, we will write centimeter cube. So this can also be written as gram per centimeter cube. Students, it is always a good practice to learn the formulae, and accordingly you should practice writing the units for different physical quantities. I have tried to show you two examples, one for speed, one for density. Likewise, most of the formulae which you will read in standard 9 for different physical quantities, they will involve in one form or the other these three or their combinations. Never forget the SI and CGS units for length, mass and time. Okay. So this you should commit to memory. After discussing about these units, next we'll proceed to this particular chapter. We'll start its content. The first topic that I'll be starting with, the position. I'll begin the discussion in first one dimension, then we'll proceed for two dimensions. Do you remember the number line, students? Suppose this is x-axis. To find position of a body, the first thing that we need to understand is the choice of origin or a reference point. So this is our origin, which we write as O, and its position we assign the value 0, x is equal to 0. To the left of origin, by convention, we put negative values for positions, likewise, like -1, -2, -3 and so on. And to its right, you know, students, we assign what kind of values? Positive values, +1, +2, +3 and +4 and so on. Suppose there is a monkey sitting at this position, which I'll call as A, position A. Before discussing position, let me tell you, position, the term position is a relative term. Now, what is the meaning of a relative term? Suppose there is a person who is standing here, the person I'll denote as P, and there is a bird sitting over here. Bird I'll write as B. My monkey is not very prominent, so I'll write it as M. It will be easier for you to understand. So P is the person, M is the monkey and B is the bird. If I ask you what is the position of this monkey, then before answering my question, you have to first ask me with respect to whom. Then The correct question becomes, what is the position of this monkey with respect to the person? Then with respect to the person, so I'll write it is like position we denote as x. Position of monkey I'll write as m. With respect to whom? With respect to person I'll write as p. Now tell me students what you should write. With respect to person, you see 1 step, 2 step, 3 units, 3 steps. So I'll write it as 3 units. Now because it is position, I'll use SI unit. SI unit for distance is meter. So this monkey is at 3 meters from person. To the right or to the left? It is to the right. So I'll write as to right of P. Instead of writing 3 meters to the right of P, I can also write it as plus 3 meters. Where this symbol plus is for this term right. It is just a convention. If you want, you can use the symbol minus for right. Usually it is often our practice to choose rightward direction as plus and leftward direction as minus, as I have indicated over here. So the correct answer is this: position of monkey with respect to the person is plus 3 meter or 3 meters to the right. Now tell me, what is the position of the monkey with respect to bird? Can you tell the answer yourself? With respect to bird, it is just 1 step earlier. So I will write 1 meter. To the left or right? It is to the left of bird. And if it is to the left of bird, I will put what kind of sign, students? It should be minus. So I will write minus 1 meter. So is this clear what is the meaning of position, students? So whenever we are writing about position, you must indicate with respect to whom. If the reference point is not given, then you simply assume that the reference is origin. If I write position of monkey and I don't indicate the reference, that means it is understood that the reference is origin. The origin is usually the universal, or I should simply say it is the reference point. Unless stated, you always choose origin as the reference. If somebody asks what is the position of the monkey, position of monkey with respect to reference, that is origin, is how many steps? 2 steps. To right or left? Right. I should write it as plus 2 meter. So this is the concept for position, first concept. After position, the next concept that I will discuss is path length or distance. The next concept, as I told, path length. As the name suggests, this is nothing but the length of path which is travelled by a body. Suppose there is a person who starts from this point I'll call it as A, and it moves to right by 1 units, it turns back, moves to the left to this point and stops there. I'll choose these points as B and C. The initial and final positions we denote as position we have already discussed. The initial position I'll write as xi. The term x means position. I for initial. Where was the position initially? It was at point A, that is plus 2. Where is the final position? Final position I'll write as xf. X is position, f for final. It is at C. C position is minus 1 meter. And position of point B is 3 meter. Path length is equal to the length of the path which is traversed by the body. The body moves from A to B and then back from B to C. So it should be from A to B plus the distance from B to C. Now how much is AB? Now before I discuss that, let me tell you, while writing path length value, path length can also be written as distance. It is the distance. It has nothing to do with direction. Whether you go to the left or to the right, it has to be assigned positive value. A to B, how much distance it travels? Just 1 meter. So we'll write 1 meter. Then from B to C, what is the distance? You see from here, 1, 2, 3 and then 4. It has 4 units. So 1 and 4 together, that becomes 5 meters. Yes, that's it. So this is the meaning of path length. While finding path length, you have to move along the actual path. So it is the length of actual path traveled. Whatever path is traced by the object, the length of that path is equal to path length. Having understood path length, the next concept that we will discuss is displacement in the same context. Now, as we have seen in this particular example, the initial and final positions of the particles are as indicated at A and at C. For finding displacement, the first thing that you should do, students, remove the concept of path from your mind. Forget about the path. So just remember, where did it start and where did it end? It started at point A and it finished its journey at point C. So I'll remove the path. I'll rub the path. Forget about the path for finding displacement. Now you see the figure. It started from point A and it ended at point C. If I ask you what's the shortest path to move from A to C, you can guess it should be straight line starting from initial position A and terminating at final position C. It is this length from initial to the final position that is called as displacement, and it has an associated direction. What is the direction of displacement? It is towards left. How to find displacement? So displacement will be given as final position minus initial position. Now what is final position in this example, students? It is -1. Minus, what is initial position? Initial position is 2. So minus and 1, -2, that becomes how much? -3 meters. The minus sign here, it means towards left. So you can also write this as 3 meter towards left. In this way you have to find displacement. So we have seen what is the meaning of position, what is the meaning of path length, and what is the meaning of displacement. Having understood this, we'll do one example. Before doing that example, let me make it very clear. If displacement is towards left, we indicate it by negative sign. It is not a rule, it is just a convention. I am assuming that we'll take right direction as positive, left direction as negative. So let us try to have an example relating displacement, path length and position. Again we take the help of this number line, and as I have indicated here, to the right direction we have taken the convention of positive sign, and if the vector is towards left direction we will use negative sign. Suppose there is some body which starts from this point, which we call as A. It moves to the right to point B, takes a sharp turn and then reaches to point C and again takes a turn, reaches to point D. It starts from A, moves to B, from B it takes a turn, moves to C, and from C he again takes a turn and moves to D. The question, first question, write the position of the body initially and finally. That means you have to write what are the initial and final positions of the body. So what will be answer, students? How do we denote position? I have told we have to denote it by x. Initial position will denote as xi and final position will denote as xf. Now tell me, students, from the figure what is the initial position? Initially it was at A and the position A refers to -1. So initial position was -1 meters. That means it is 1 meter to the left of origin. Final position, where does it end? Does it end at B or C or D? Of course, it ends at D. This was initial, this was final position. What is the position of D? D is exactly over the origin. So no problem, we'll write its position as 0 meters. So its initial and final positions are -1 meters and 0 meters. The second question in this, what is the path length? What is its path length? Now you know, students, path length is nothing but the total distance traveled from initial to final position. We have to see, we have to move along the path. The path goes from A to B, B to C, C to D. So the path length will be A to B plus B to C plus C to D. Now tell me, students, what is the length from A to B? You have to count on the number line. 1 step, 2 steps, 3 steps. In units of distance, we'll write 3 meters. So we'll write it as 3 meters. Next, we have BC. Can you tell me how much is BC? From B to C, you see 1, 2, 3 and 4. So it has the value 4 meters. And third term C to D 1 and 2. So it is 2 meters. And therefore, what will be the sum equal to? The sum will be 3 plus 4 plus 2, that is 9 meters. In this way, we will find the path length, that is the distance. After finding distance, the third question in this that I would like to discuss is the displacement. Question number 3. What is displacement? Tell me, students, how to find displacement. So we have already discussed displacement is the shortest path from initial to final position. The best way to do that, I have told you, from first locate the initial and final positions. After doing so, remove the path from your mind. I'll rub the path. Path I will rub. So initially the particle was here at A and finally it is at D. This is the position. This is initial, this is final. Move straight from the initial to the final position. This is your displacement. It's very easy. How much is its value? Its value is only 1 meter. And this arrow is important in case of displacement. So what is the arrow pointing? Where is the arrow pointing? It is pointing towards right. So the answer for displacement, don't write simply 1 meter. It is incomplete answer. This simply tells you the value. I have told you displacement also has a direction. In this case, I have told you it is 1 meter towards where? Towards right. And I have told you the convention, right direction we usually take it as positive. So we'll take it as plus 1 meter. So here initial and final positions we have discussed. We have discussed how to find the path length, and we have also discussed how to find the displacement. Let us see one more example. So we'll quickly discuss one more example. Suppose a body starts from this point, it goes to the left and again takes a turn, moves to the right. It starts from point A, it moves to point B, takes turn, reaches to point C, and again takes a turn and reaches back to the point A. These points A and D are at same position. Note that this is not the actual path. Actual path is on this axis. It is moving like this. I am showing the path from A to this point, then from this point to this point, and from this point to this point. But just to remember the path, I have indicated that. I am again pointing. This is not the actual path. Actual path is on which axis? On the x-axis. Now tell me, students, in this figure, what are the, again same questions which we did in the first case, what are initial and final positions? I hope it's very easy for you now. Initially it was at A and A is at position 1, so we'll write plus 1 meters. What is the final position? It is also at point D. See, I'll encircle the initial and final positions. Both initial and final positions are at the same point, so no problem, 1 meter and 1 meter. Second one, I asked you about path length. So path length is also called as what? It is called as distance. What will be its value, students? Just follow the path. It started from A to B plus B to C plus C to D. How much is AB? AB you just count 1, 2. So it is 2 meters. How much is B to C? 1, 2, 3, 4. So 4 meters. And how much is C to D? 1, 2, 2 meters. So total how much it becomes? 8 meters. 2 plus 4 plus 2, that is 8 meter. So we have got the initial and final positions. We have also got the path length or distance. The third one, that is displacement. It is obvious. Displacement, I have told you, students, how to find it. We find displacement using the formula xf minus xi. Final position minus initial position. For displacement, I have told you, students, remove the path. So I'll remove the path. After removing the path, what do we find? We find it was at this position initially, and finally also it is at the same position. So xf minus xi, this becomes 1 meter minus 1 meter. That is how much? 0. Displacement can be 0 also after traveling through some distance, and that's why I chose this example. Distance, if particle has undergone some motion, if it has moved, then distance can never be negative or 0. It will have some value, but displacement can be 0. Previous example we have seen displacement was negative. Negative means towards left, and in some cases it can be positive. Positive means towards right. Let us recapitulate. Let us summarize the differences between distance and displacement. So I told you distance and displacement. So distance, first point, it is nothing but path length. It is the length of actual path traversed by a body. On the other hand, displacement is relative position of final point with respect to initial point. It depends upon path, the distance depends on path followed. But we have seen some examples wherein I told displacement, we don't bother about the path. We write it does not depend on path. Distance, we have seen, it is always positive. It cannot be 0 or negative. If the object has moved, if there is no motion, distance can be 0 also. But if there is some motion, distance cannot be negative, it cannot be 0, it has to be positive. But displacement, even when the object has moved, displacement can be negative, it can be positive, and it can be 0. And the most important of all of them, distance has nothing to do with direction, it has only value. Such quantities are called as scalars. The scalar quantities are those, so distance, for example, so it has magnitude but it does not have any direction. No direction is to be specified for writing the distance. But in vector quantities, those quantities wherein we write some value and we associate some direction to it are called as vectors, and displacement is one among them. So displacement is a vector quantity. That means it has a magnitude as well as a direction. I'll stop here, students. In the next class, we'll go over to speed, average, velocity, and so on. But before I go over to the next lesson, it's my request to all of you, kindly read these contents properly, make notes, use NCERT textbook, make notes in your notebook, and if possible, try to solve some of the examples given in your NCERT. Next class, I'll be putting some assignments based on the 2 classes. So be prepared for the assignments, and before that, as I told, please recapitulate them before attending the classes. And I'll suggest one more thing, please be with your notebooks and follow NCERT. Thank you, students. I hope all of you are fine and take good care of your health. Meeting you in the next class tomorrow.